Assalamualaikum students. Students, in this recorded lecture, I'm going to do the questions of electronic configuration, the MCQ especially, that you people find a bit hard, and sometimes you don't understand, like you have problem with the comprehension, right? Like sometimes you solve the question, but you're taking too much time. So to do these questions, I'm going to share my screen with you, but when I'm sharing my screen, I'm your teacher, Zeenat. So, you are supposed to like, subscribe, and share my channel. And I'm sharing my screen and I'm opening the past papers. I'm putting off the video, stopping the video, right? I'm opening the MCQs. You will find these MCQs on my website, Chemistry by Zeenat, right? Now look, I can share this with you. See. Chemistry by you can see these in the resources. Go to AS. In the ASP one, see, this is your the first chapter was mole, and now this is what. Look, you can see all these past papers, right? These are questions. These are given here to you, and the notes are also available here. So I'm going to share these with you so that you understand that how to solve these. Atomic structure, where are the questions? This one. Look, the first question is, what is the total number of which isolated gaseous atom has a total of 5 electrons occupying spherically shaped orbitals? Now, spherically shaped, you want to find all the electrons, the 5 electrons in spherically shaped orbitals S. Total 5 electrons in spherically shaped orbitals. So what you are supposed to do? The simplest way is, don't waste your time, book for configuration, because you have to find all. So you need the configuration. Boron is what? 5. Boron is 5. 1 is 2, 2 is 2, 2p1. Fluorine, 1 is 2, 2 is 2, 2p6, sorry, 2p5. And then sodium. 1 is 2, 2 is 2, 2p6, and 3 is 1. Like, look, you can go this way. 1 is 2, 2 is 2, 2p6. This is 3 is 2, so this is what? 3 is 1. 1 is 2, and then what? 2 is 2, and then what? 2p6, and then what? 3 is 1. So, if you see, how many electrons? 4 in the next. 4 and spherically shaped, but in this, 4 and 1, 5. The answer is C. Sodium has 5 electrons in spherically shaped orbital. This is easy, this I'm leaving. Look at this question. This is a bit different. Look. Which element has an equal number of electron pairs? Number of electron pairs, not electrons. Not paired electron, pairs. And unpaired electrons within the principal quantum number 2, second shell. What is the meaning of this? In which element the electron pairs are equal to the number of electron pairs are equal to unpaired electrons in the second shell of atom. So beryllium, you know 1 is 2, 2 is 2. It's what? Beryllium is 4, yeah. 1 is 2, 2 is 2. Carbon is 6. 1 is 2, 2 is 2. 2p2. Nitrogen. 1 is 2, 2 is 2, 2p3. Oxygen. 1 is 2, 2 is 2, 2p4. Right? This is 6, this is 7 atomic number, this is 8. Now your question is about what? Which element has equal number of electron pairs and unpaired electron with the principal quantum number 2 second shell? So the question is not about the first shell. So I'm going to cut it down. The second shell, the question is not linked. Now, in beryllium, this is what? 2s. This is 2p. I have the facility of iPad. I can draw this again. Oh, I want to remove this. Now, beryllium, now for carbon, now for nitrogen. Now I'm doing this for oxygen. See, in the second shell. One pair, non-paired electron. One pair, two unpaired. One pair, one pair, and three unpaired. And here it is 4. So 2 paired. So see, look, equal number of electron pairs. So 1 pair, non-paired, 1 pair, 2 unpaired, 1 pair, 3 unpaired, 2 pairs, 2 pairs, 2 unpaired, 2 pairs, 2 electron pairs equal to what? 2 unpaired electron. The answer is G. Equal number of electron pairs with unpaired electrons. So 2 electron pairs and 2 unpaired electron in the second shell in the principal quantum number 2. And exactly the same type of questions again, but now it's a bit different, a bit. Which atom has more unpaired electron? More than paired electron in principal quantum number 2, in second shell. Unpaired electrons and paired electrons, not pairs, paired electrons. Like if it is like this. So how many pairs? 2 pairs. But how many paired electron? How many paired electron? 4. Pairs are 2, but paired electrons are 4. And the question is about paired electron less than the unpaired electron. So carbon 6, 7, 8, 9. 1 is 2, 2 is 2, 2p2. 1 is 2, 2 is 2, 2p3. 1 is 2, 2 is 2, 2p4. 1 is 2, 2 is 2, 2p5. Now, what am I supposed to do? I can't paste it. Okay. The question is about second shell again. I'm cutting the 1s. And I'm left with what? This. So I'm doing this how many times? Definitely 4 times. Now 1s2, 2s1, sorry, 2p2, 1 and 1. Sorry, no. It's 2s2 and 2p3, 3 single. Now this is 2s2, 1, 2, 3, 4. 2s2, 1, 2, 3, 4, 5. So unpaired electrons are 2 and paired electrons are also 2. Unpaired are 2 and paired are 2. Unpaired are 3 and paired are 2. Unpaired are 2 and paired are 4. Unpaired is 1 and paired are 6. And what are we searching for? Huh? These are unpaired and these are what? Paired. So unpaired more than paired. The answer is what? B. In which pair do both species have only one unpaired P? Now, look how we are supposed to do this question. This is very important. For this, I'm going to uh, delete this lower space. Look how I'm making it clear so that I can solve this. I want to show you a method. I like it. It's very easy. This is your, these are your, these O levels. This. I'm bringing this much part. See. Look. How many electrons? What are they saying in the question? They are saying, in which pair do both species has one unpaired P? The first thing, if it is P1, like if I write it, so many times, wait a minute. Let me tell you one thing. P1, P2, P3, P4, and then P6. Look, if it is P1, one unpaired. If it is P2, two unpaired. If it is P3, three unpaired. But if it is P4, two unpaired. If it is P5, one unpaired. But if it is P6, P6, it is what? Zero unpaired. So one unpaired and one unpaired is only possible when it is what? When it is either P1 or P5. Now see. If it is argon plus, I need one unpaired P. So I need what? Either P1 or P5. Right? Now look. This is Ar plus. This is argon. Ar plus means it is losing an electron. If it loses one electron, will this become P5? Yes. Argon is what? P6. But if it is argon plus, it becomes what? This. So in the first option, it is plus. It becomes what? Like chlorine P5? Yes. C minus. This is C minus. It's gaining one electron. When it is gaining electron, it become like this. It becomes what? P3. Not correct. Now next, boron. This is boron. Boron is already P1. Yes, perfect. Ti plus. You know, when it is suppose C minus, it's like this. When it is C minus 2, it's like this. When it is C minus 3, it would be like fluorine. Now when fluorine is F minus, it becomes neon. If it is plus, it becomes like O. If it is plus 2, it's losing 2 electrons, it becomes like nitrogen. Like look, when aluminium is plus, it is like magnesium. But when aluminium is minus, it's like silicon. If it is minus 2, it's like phosphorus. It's like minus 3. This thing is possible the way that I'm doing. Like by putting minus or plus, with the minus, I will go this way. With the plus, I will go this way. Huh? Like if it is plus, you will go behind here. But if it is, now you must know that they are all plus 1, they are all plus 2, P1, P2, P3, P4, P5, P6. Now for positive, you will go to left hand side. For negative, you will go to right hand side, depending that it's how much negative, how much positive. Just a minus one. So, like for minus one, go one further. For minus two, two step. For minus three, three steps. But this is not for this area. No. You know what you are supposed to do? For such elements, do the normal configuration. Huh? Do the normal configuration. What is the normal configuration of titanium? Titanium is, look, I'm doing it. Titanium is argon, 3d2 4 is 2. Huh? Like what? Titanium is argon 4 is 2, 3d1, 3d2. Titanium is argon 3d2, 4s2. Now when titanium is plus, huh, you are supposed to make it to lose only one electron, and that is also from 4s, not from 3d. I told you people that, like, it's like this. Argon 4 is 2 3d1, argon 4 is 2 3d2, argon 4 is 2 3d3. Like after filling 4s, the remaining electron enter into 3d. Right? So actually, electron enter into 4s first, remaining into 3d, but once it is positive, losing electron, which electrons are lost first? The one which are in 4s. So if it is plus, what is left? 4 is 1. There are how many unpaired now? In D, there are 2 in D and 1 in S. So total how many unpaired? 3 unpaired electron. Right? So the answer is not this. Fluorine. Fluorine is what? P5. Perfect. 1 unpaired. Gallium is gallium. See? P1 in this group. These are P1, these are P5. Answer is this. Now what about this? Se minus. When it is Se minus, it's like this. Huh? Se minus is like this. P5. Si minus. P3. And what we need? C. C is the correct answer. I hope you understand. Now, the next question, see. The next question. In which pair do both atoms have one electron only in an s orbital? In the ground state. Ground state means the configuration that we do. The one that we do, 1 is 2, 2 is 2, 2p6, 3s2, this is called ground state because the filling of electron is on the basis of energy. Low energy is filled first, ground state. So, one electron, both have one electron in S. If it is calcium, it is what? S2? Incorrect. Scandium, you know, it's scandium. This is scandium. Huh? It's what? It is argon 3D14S2. So not incorrect. Copper is what? Copper. Argon 3D104S1. Perfect. Possible one electron in S. Beryllium. In beryllium, S2, not. Hydrogen, 1s1. Helium, 1s2, not. Lithium, group 1, 2s1. Yes. Chromium, see, D5 4s1. Argon, 3D5 4s1. 4s1, the answer is D. Huh? Next. See, there are so many questions about unpaired electron. Huh? Which atom has exactly 3 unpaired electrons? 3 unpaired. Aluminium. Aluminium, 3p1. At the end, 3p1, 1 unpaired. Carbon, 2p2, 2 unpaired. Chromium, argon, 3d5 4s1. 1 unpaired, 2 unpaired, 6 unpaired. Phosphorus, P3, 3p3 at the end, 3 unpaired. And this question is kind of repeated again the same. I am not doing it. I am going to another question. Look at this. How many valence electron and unpaired electron are present in one sulfur valence electron? How many valence electron? The valence electrons are the valence shell. Like you have to look at the whole shell, the third shell. 4, 5, 6 unpaired electron. These are paired in P4. In P4, 1, 2, 3, 4. 2 are unpaired. Now, configuration of neon. So you are supposed to do normal configuration, then remove electron first from 4s, right? Keep in mind. So nickel is 28. If I do this configuration, 1 is 2, 2 is 2, 2p6, 3s2, 3p6, 18, 19, 20, and 28. I can do this configuration, and in place of this, I can write what? Argon 3d8 4s2. This is what? Remove the 4s electron. What is left? 3d8. So the answer is what? D. I'm leaving these questions. I'm in search of another question. Like 6 unpaired is clear-cut chromium. This question, I love this question. 3p. Which statement about a 3p orbital is correct? Which statement about a 3p orbital? Orbital accommodate only 2 electrons, right? 3p orbital, they are using the word orbital. In orbital, only 2 electrons. In subshell, 6 electrons. It can hold a maximum of it can hold a maximum of 6 electrons. No, incorrect. The question is about orbital, not about subshell. Right? Incorrect. It has highest energy with the orbital with principal quantum number 3. No. In 3, there is 3s, 3p, 3d. If quantum shell is the same, if same quantum shell, F has more energy than D, D has more energy than P, P has more energy than S. So, like 4F, 4D, 4P, 4S. So the energy of highest energy, no, it's incorrect. It has higher energy than 3S. Yes, 3p has higher energy than 3s, but same shape? Not at all. Not at all. It is occupied by one electron in isolated phosphorus. 15 atomic number. 1s2, 2s2, 2p6, 3s2, 3p3. In 3p3, there are 1, 1, 1. Yes. I hope you understand that what you are supposed to do. Which atom has outermost electron with the principal quantum number 3? Huh? Outermost with the principal quantum number 3 and orbital of this. So it's what? 3p. Electron in 3p. So if I bring the periodic table down, look. See? Outermost in P. Sodium. Outermost in S. Chlorine, outermost in P. Bromine, outermost in P. Calcium, outermost in S. So it's either chlorine or bromine. Now the outermost in third, first period, second period, third period. So it's chlorine, third period, 3p. This is fourth period. So answer is what? B. I hope you understand. And now you are supposed to do the question from these. But one thing you have to do, you can do like for O2 minus. What am I supposed to do? I'm not going to do much more. O2 minus is like neon, but like for O, I'm going this way, but I'm not going to do the same for chromium, nickel, and iron. Why? I will write their configuration like this. Copper, look. Argon, now I'm going for shorthand. Argon, after argon, what? 4s2. After argon, 4 is 2 and what? 3d9. But since it's copper, it's what? 4 is 1, 3d10. Now what you are supposed to do to make 2 plus? Remove electrons from 4s and then 1 electron from this. So what is left? 3d9. Right? In chromium, how you will do? Like what is the configuration of chromium? Chromium is argon. 4s, not, it's also 4s1, 3d5. So what are you supposed to do? 1, 2, 3. So what is left? 3d3. Like in transition, do the normal configuration, then remove electron first from 4s and then from 3d. Right? See you in the next lecture with atomic radius. After this, we are going to do what? Wait a minute, let me show this to you. My next topic is about what? Atomic radius, right? And after atomic radius, then we are going to do what? Ionization, ionic and atomic radius, and then ionization energy. Ionization energy. Okay, guys, like, share, and subscribe my channel. I hope you understand. Allah Hafiz.